Okay, so here we go with some more factoring examples. We're going to factor 3x squared plus 2x minus 21. I'm just going to do this by the sort of trial and error, figure out what has to go where method, because that's what I like best. That works fine if you can see what to do. If you like some other method better, like the AC method that I was talking about at the end of the last video, you can do that. Just whatever works for you. That other method is maybe a little more systematic, but it might be a little more work. Whereas this method, if you can just see what works, you might be able to do things more quickly this way. So anyway, what do these two factors have to start with? The first terms have to multiply together to give you 3x squared. So you'd have to have a 3x times an x. And then what can they end with? The numbers on the end have to multiply together to give you negative 21. So to multiply up to a negative, you need a positive times a negative. One's plus, one's minus. Whatever I put on the outside will get multiplied by the 3x, and whatever I put on the inside will just get multiplied by the 1x, and then those two things have to combine to give you plus 2x. So what numbers can you think of that do multiply together to give you 21, or negative 21? Well, how about a 7 and a 3? Can we put a 7 in one of these spots and a 3 in another, make one of them plus, one of them minus, and have it work out so the outside and the inside add up to plus 2x? If you want some time to think about it or try a few possibilities, you can pause the video. And it turns out that what works is 3x minus 7 times x plus 3. We better check that. If I multiply that out, we get 3x squared plus 9x minus 7x, so there's your plus 2x, minus 21. How about this one? 2x squared minus 11x plus 15. It's going to have to start with a 2x times an x to get 2x squared. It's going to have to end with numbers that multiply to 15. So either a 5 and a 3, or a 15 and a 1, or a minus 5 and a minus 3, or a minus 15 and a minus 1, and we have to decide which one goes where, because the one that goes here is going to get multiplied by 2x, and the one that goes here is going to get multiplied by just the 1x, and we need those outside and inside to add up to minus 11x, and it turns out that what works, we might have to try a few things, but the one that works is, they're both minus, and we put a 5 on the inside and a 3 on the outside, so it's 2x squared minus 6x minus 5x, there's your minus 11x, plus 15. Okay, how about this one? 5x squared plus 35x plus 60. Okay, to get a 5x squared, we would need a 5x times an x, and then we got to think about what we could put here and here that would multiply together to give you 60. Think about what numbers multiply up to 60. You could have a 6 times a 10. You could have a 20 times a 3, a 15 times a 4, a 60 times a 1. There's a bunch of different possibilities. But wait a minute. There's something else going on here. Do you see what it is? Before we try messing around with this, we should look to see if there's a common factor that we can factor out. Is there? Why, yes, there is. There's a common factor of 5. All three of these terms can be written as 5 times something else. So before we do anything else, we should pull out that common factor of 5. So here we go. 5 times x squared plus 7x plus 12. Now, can we do anything with that x squared plus 7x plus 12? Well, turns out we can. We can break it up into x plus 3 times x plus 4. And yay, we're done with the factoring. Now, if I hadn't noticed that, what if we had continued on with this, tried plowing ahead with figuring out what numbers we can put here and here that multiply to 60 and give us an outside and an inside that add up to 35x? It might have taken us a while, but we might have figured out, oh, if we put a 5x plus 15 times an x plus 4, it's factored. But we wouldn't want to just leave it at that. That's not a good final answer because that's not factored completely, because 5x plus 15, we can still do something with that. We can take that and pull out a 5. And when we do, it's 5 times x plus 3 times x plus 4. But it's easier to pull out the common factor first, because then the numbers that you have left to deal with aren't as big. There's not as many possibilities when you think about how to multiply. So always start by looking for a common factor. If you can find one, factor it out and then look to see if there's something else you can do. So let's try it on this. 2x cubed plus 6x squared minus 20x. See a common factor we can pull out? If you said 2, you're half right. 2 is a common factor, but it's not the greatest common factor. The greatest common factor is 2x. So if we start by pulling that out, we get 2x times x squared plus 3x minus 10. And now can we factor this? Can we break this up into two pieces? They would start with x's. They would end with numbers that multiply to negative 10, and then to get a plus 3x in the middle, have an x plus 5 times an x minus 2. And finally, what about x squared plus 7x plus 13? I don't see a common factor. So let's see if we can break it up into, they'd have to start with x's, x times x to get x squared. They'd have to end with numbers that multiply up to 13. I think the only choices there are 13 times 1, or negative 13 times negative 1. But that's not going to give us our 7x in the middle. That's going to FOIL to x squared plus 14x plus 13. So what does that mean? Well, it means this cannot be factored. Anything that might possibly give us a 13 on the end is not going to give us the 7x in the middle. So that happens sometimes. There are plenty of polynomials out there that cannot be factored. If you just meet a polynomial at random, the chances that it can be factored or not factored, a lot of them can't be. Now, if I give you polynomials and say, hey, factor this, usually it's one that you can factor. Because it would be kind of dumb and useless if I gave you a bunch of polynomials and told you to factor them and they couldn't be factored. But if you just wrote down a polynomial at random, there's a pretty good chance that it can't be factored. So don't give up too soon. But if you've tried everything and nothing works, then it means that your polynomial just doesn't factor. And if you want to know the secret, a secret hint for how you can tell whether the polynomial can be factored or not without just running through all the possibilities, if you calculate b squared minus 4 times a times c, if that comes out to be a perfect square, that is something you can take the square root of and just get a nice whole number, that's when you can factor the polynomial. So like on this one, b squared, 49, minus 4 times 1 times 13, 49 minus 52 would be negative 3, not a perfect square. This can't be factored. But on some of those others we were looking at, like well, how about this one? B squared would be 121. Remember, when you square a negative, you get a positive. 4ac would be 4 times 2 is 8 times 15 is 120. And then 121 minus 120 is 1, which is a perfect square. So that's how I could tell that this is factorable. So you don't have to know that. In fact, I don't usually teach that. That's kind of a secret, but if you want to know, there it is. And the reason it works, well, it's related to the quadratic formula. That's all I'm going to say.